Okay, welcome back to Mr. Hassan's Maths channel. This is question number 12, part B from the May-June 2020 International IGCSE Paper 4 Variant 3. And this question here is about graphs of functions. And this is a very short question, but it's in this topic of graphs of functions, so I've saved it as a separate video from part A. Now it tells us here that the graph of y equals x squared minus x plus 1 is shown on the grid. Here we see this is a quadratic function. It says, by drawing a suitable line on the grid, solve the equation x squared minus 2x minus 2 equals 0. So we got to use this equation, which I'll write down here, y equals x squared minus x plus 1. So this is what's drawn. So I like to set my work out like this. What's drawn is y equals x squared minus x plus 1. That's what's drawn. And we have to solve the equation given, which is x squared minus 2x equals 0. So we have to use this equation to solve x squared minus 2x minus 2 equals 0. So we have to use this equation to solve this. So we have to use this graph that's drawn to solve this equation. Now, the way to do that is to modify the equation given to solve. We can't modify the equation that's drawn because that's what's drawn. Can't change that drawing. But we can change the equation such that what we have to do is you have to try to make it look exactly like what's drawn. We have to make one side of this equation look exactly like what's drawn. So what we can see, the x squared is fine. We don't need to change that. But the minus x has to become negative 2x. How do I make minus x into negative 2x? Well, how do I make minus 2x become minus x? Sorry, I have to do the other way, as I said. This has to become like that. So minus 2x has to become minus x. Minus 2x has to become the same as minus x. So I need to add x. When I add x to this, this is going to become x squared minus x. So that's that part done. And the negative 2 has to become positive 1. How do I make negative 2 positive 1? Well, I have to add 3 to it. If I add 3, okay, to this, I'm going to have minus 2 plus 3, which is plus 1. So, as we know, what we do to one side of an equation, we must do to the other. So on the other side, I have to also add x and add 3. So I'll end up with x squared minus x plus 1 equals x plus 3. So this is the equation now where it's the same equation as this. The equation is just modified by adding and subtract, or basically adding the same thing on both sides of the equation. All right, so we haven't changed the equation, just changed the way it looks. But now one side of the equation looks exactly like what's being drawn. So how do I now find the solution to this equation? I need to find where this intersects with that. So I have to draw the line y equals x plus 3. When I draw that line on this grid, I find the places where that line and this curve intersect. I will then be able to solve this equation. So I have to draw the line y equals x plus 3. Now the line y equals x plus 3, if I want to draw this, I know that the gradient is equal to 1 and the y-intercept is equal to 3. So there's different ways we can draw this actually. Now one of these ways is this method I'm going to show you now. So we know it goes through 3 on the y and the gradient is equal to 1. All right, now the gradient is equal to 1, which is the same as 1 over 1. So it's like you can say it rises 1 and runs 1. So for every 1 unit it goes up, it goes across 1 unit. So from 3 to 4 on the x and from 0 to 1 on the y, it's going to go through these 2 points. That's one way of drawing this line. Okay, so I'm going to draw this line and I'm going to make the drawing thin so that it doesn't so it's accurate basically. So I'm going to draw this line and make sure you make it cover the whole axis. You should use a ruler here, of course, when you draw it, and a thin pencil, sharp pencil, and the graph will look something like that. That's one way of drawing it, using the intercepts. Using the gradient and the y-intercept. Another way is to draw it in the following way. You can say when x equals 0, y equals 3. That's the point 0, 3. And you can say when y equals 0, then x equals negative 3. That's the point negative 3, 0. So we know it will go through this point here. But I should make this a bit more accurate. And now it goes through this point here and that point there. So that's another way you can draw it. Find the y-intercept and the x-intercept by putting x equals 0 to find the y-intercept and y equals 0 to find the x-intercept. So you find those two intercepts and you join them together. You get the same line. Okay, or you can even draw it by just saying when x is 0, y is 3, for example. When x is 2, for example, y is 5. You can choose any point, two values of x within this range and plot them, and then you just need 2 points to draw a straight line. You don't need lots of points. Okay, it's a straight line. Now, so we've drawn the line, but we haven't finished the question. It says, solve the equation. So we have to find the x values of where these intersect. So I'm going to draw a very thin line, okay, at these points where they intersect, going down to the x-axis, vertically down to the x-axis, and I have to read off those values on the x-axis of where they intersect. So try to be as accurate as possible and show your steps by drawing these lines. Don't just write the answers down. Draw the lines on your diagram to show that you have used this graph. So this is like negative 0.5, and I think as 0.678, yeah. So that's like negative 0.567, negative 0.75, and here we got 2.567, 2.75. Okay, it's like 2.5, 675, 2.75. So those are the two x values. X equals negative 0.75 or x equals 2.75. Those are the solutions that we've solved this equation graphically. Now, if you have time in the exam to, try to figure out the answer algebraically, you could use a quadratic formula to solve this equation and see if the values come out the same as these two values. Or, of course, it will come out something close, but not the same, because these are rounded values, and this won't. I don't think this will factorize or give you an irrational number, but they should round to give you something close to this. But you don't need to do that if you're confident you've done it right. Just if you have time and you want to make sure you haven't made a silly mistake, you could do that. All right, so that's how you deal with these questions. You look at what's drawn, you don't change that. You look at you've been asked to solve, you change, that's what you have to modify, so that one side of the equation looks like what's drawn. So the minus 2x has to become minus x, so you add x. The minus 2 has to become plus 1, so you add 3. But what you do to one side, you do to the other. So basically end up with this equation here, which is, where to solve this equation graphically, you draw y equals whatever's on the other side, and when they intersect, you write down those x values. And that's the end of that question. This is an important question. I think it's kind of almost like it's starting to come up more often now in the new syllabus. So I thought it was important for us to go through that. So other questions from this particular paper, which is May, June 2020, can be found in the playlist that should appear in this area on the screen at the end of the video. Other questions about graphs or functions can be found in the playlist appearing in this area. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.